Welcome to today's paper reading. Today's paper is titled Code Generation with AlphaCodium, From Prompt Engineering to Flow Engineering. This paper was published on the AR14 preprint by Ridnik and colleagues from Codium AI. The abstract highlights the unique challenges in code generation, which differ from typical natural language problems. These challenges include the need for exact syntax matching, identifying both happy paths and edge cases, and addressing numerous small details specific to code. In response to these challenges, the authors propose a new approach called AlphaCodium. This approach is a test-based, multi-stage iterative flow designed to improve the performance of large language models, LLMs, on code generation tasks. The effectiveness of AlphaCodium was tested on the code contest dataset, which includes competitive programming problems. The results show a significant improvement in accuracy, with GPT-4's pass at 5 rate increasing from 19% to 44%. The authors believe that the principles and best practices developed through this work are applicable to a wide range of code generation tasks. The introduction of code generation tasks presents a significant challenge due to the vast and structured space of possible programs. Correct solutions can vary greatly, and assessing the utility of partial or incorrect solutions is complex, especially since a single character change can drastically alter a solution's behavior. Transformer-based language models have shown success in generating code for simple programming tasks, but real-world problems often require more nuanced solutions defined by lengthy natural language descriptions. The code contest dataset, curated from competitive programming platforms like Codeforces, addresses this by providing a more challenging set of problems with comprehensive evaluation capabilities, including a private test set with over 200 unseen tests per problem. Figure 1 illustrates the AlphaCodium flow for code generation, showing how direct prompts struggle to solve complex code problems. Iterating on public tests helps stabilize and improve the solution, but may leave blind spots due to the limited comprehensiveness of public tests. The full AlphaCodium flow, which includes a pre-processing phase and iterations on both public and AI-generated tests, further enhances the solution, leading to a higher solve ratio. The code contest dataset, introduced by Google's DeepMind, consists of 10,000 code problems sourced from competitive programming platforms like Codeforces. It includes a validation set of 107 problems and a test set of 165 problems, designed to evaluate the ability of large language models, LLMs, to solve challenging code problems. Unlike other datasets, Code Contest uses a comprehensive private test set to ensure the robustness of generated code solutions, with each problem containing approximately 200 private input-output tests. The dataset's problem descriptions are intentionally complicated and lengthy, emphasizing the importance of understanding small details and nuances, which are critical in real-world coding scenarios. This approach contrasts with simpler datasets like Human Eval, where problems are presented more concisely. In this work, the focus is on applying a code-oriented flow to any pre-trained LLM capable of supporting coding tasks, rather than training a dedicated model. The proposed flow for code generation involves an iterative process where the generated code is repeatedly run and fixed against input-output tests. This approach is more effective for solving code contest problems compared to common NLP prompt engineering techniques. The flow is divided into two main phases: the pre-processing phase and the code iterations phase. In the pre-processing phase, the problem is reflected upon and public tests are reasoned about to generate additional AI tests. These tests aid in the iterative process. The code iterations phase includes generating possible solutions, ranking them, and iteratively running and fixing the code against selected public and AI tests until the tests pass or a try limit is reached. This iterative approach ensures that the generated code is validated and refined to improve accuracy and robustness. Figure 2 illustrates a typical problem from the code contest dataset, showcasing a lengthy and complicated problem description. The figure also includes an AI-generated self-reflection on the problem, which helps to clarify and make the problem more coherent. This self-reflection is crucial for improving the generation of correct code solutions, as it aids in understanding the problem's nuances and details, which are often critical in real-world coding scenarios. In this section, the authors discuss several key design concepts for code generation. Firstly, they emphasize the use of structured output, specifically in YAML format, which simplifies complex tasks and eliminates the need for extensive prompt engineering. This approach allows for a more straightforward presentation of tasks and facilitates the generation of complex, multi-stage solutions. Secondly, semantic reasoning via bullet points analysis is highlighted as a method to improve the model's understanding of problems. By requiring output in bullet points, the model is forced to break down the problem into logical sections, leading to better results. Lastly, the authors advocate for modular code generation, where code is divided into small, named subfunctions. This approach results in fewer bugs and enhances the model's ability to iteratively fix issues. Figure 3 provides an example of a prompt that utilizes structured output in YAML format, specifically designed for generating possible solutions in a code generation task. The prompt includes detailed Pydantic class definitions, ensuring that each solution is comprehensive and adheres to the problem's rules and goals. The output is a list of possible solutions, each containing fields such as name, content, y_it_works, and complexity, ensuring a clear and methodical approach to problem solving. The results show that AlphaCodium significantly improves the performance of large language models on coding problems. For instance, on the GPT-4 validation set, the pass at 5 score improved from 19% to 44%, representing a 2.3 times improvement. When compared to other methods in the literature, such as CodeChain and AlphaCode, AlphaCodium consistently achieves better results. Notably, AlphaCodium requires far fewer LLM calls per solution, performing around 15 to 20 calls per solution and approximately 100 calls for a pass at 5 submission, which is 4 orders of magnitude fewer than AlphaCode's reported million calls for similar performance. Table 1 compares the performance of the AlphaCodium flow against direct prompts on various models. The metric used is pass at K, which measures the percentage of problems solved using K-generated solutions per model. The results show that the AlphaCodium flow consistently and significantly enhances the performance of large language models, LLMs, on code contests problems. This improvement is observed across both open-source, DeepSeek, and closed-source, GPT, models, as well as in both validation and test sets. Notably, for GPT-4 on the validation set, the pass at 5 score improves from 19% to 44%, representing a 2.3-fold improvement. Table 2 presents a comparison of AlphaCodium's performance against other methods from the literature. It highlights that AlphaCodium consistently outperforms CodeChain when using the same model, GPT 3.5, and metric, pass at 5. Additionally, AlphaCodium achieves superior results compared to AlphaCode, despite using a different generation methodology and significantly fewer LLM calls. This table underscores AlphaCodium's efficiency and effectiveness in code generation tasks. In this paper, the authors introduced AlphaCodium, an iterative code generation flow that runs and fixes generated code against input-output tests. The flow is divided into a pre-processing phase, where the system reasons about the problem in natural language, and a code iterations phase, which involves iterating on public and AI-generated tests. AlphaCodium incorporates several design concepts, including structured output in YAML format, generating modular code, and semantic reasoning via bullet point analysis. The authors tested AlphaCodium on the code contest dataset, demonstrating that it consistently and significantly improves the results of various models, outperforming previous works with a smaller computational budget. Thank you for watching.